Hello friends, welcome to engineering tutorial. Now in my previous 2 or 3 videos I discussed about the diode applications related to clipping circuits. Okay, so I discussed about the basic concept about clippers or clipping circuits, what is the definition and the use of clipping circuits. Then I discussed about the various types of clipper circuits that are used for various applications, and I discussed about one of the particular type of clipper circuit, which was the positive clipper circuit. So again, let us just have a quick recap. A clipper circuit is used to shape signal waveforms by removing or cutting specific parts of the signal or the waveform. So in positive clippers, which we discussed in the previous video, the positive half cycle of input AC signal was removed. Okay, the positive half cycle of the input AC signal was removed. So we discussed the circuit diagram and the input output waveform. So you please check out that video in my channel about positive clippers. So in today's video we will discuss about negative clippers. Okay, so we will discuss about negative clippers. So similar to positive clippers, you can relate the definition. The negative clipper is used to remove the negative half cycle of the input signal. In positive clippers, the positive half cycles were removed. In negative clipper, the negative half cycles will be removed. Now, this is the circuit diagram of the negative clipping circuit. Okay, you can see the input signal is applied here. Then the main part of this circuit, the main functional element of the clipping circuit is the diode, which is connected in this way with its N end upward and the P end downward. Now the resistor R is connected here to protect the diode from excessive voltage or current surge. Now RL is the load resistance across which the output is obtained. Now you can note down the difference between the positive and the negative clipper. In positive clipper, the diode was connected in this way with its P end upward and N end downward, but in negative clipper it is the opposite direction with its N end upward and the P end downward. So this is the main circuit connection difference between the positive and the negative clippers. Now let us try to understand how this circuit works to remove the negative half cycles. Okay, so let us see how the circuit functions to it works to remove the negative half cycles from the input AC signal waveform. So now we will understand the working principle of the negative clipping circuit. Now these clipping circuits are always analyzed in the same way. Okay, first during the positive half cycle of the input and then during the negative half cycle of the input. So both these cases are analyzed separately. So here first we will discuss the circuit behavior during the positive half cycle of the input signal. So during the positive half cycle, okay, the positive waveform of the input, let us say the sinusoidal signal we have taken. The top end of the circuit, this end will become positive and the bottom end will become negative. So here again the biasing of the diode, the forward and reverse biasing of the diode concept comes into play. So as you can see, the positive end, okay, the positive end is connected to the N type end of the diode and the negative end is connected to the P type end of the diode. So in this case the diode is reverse biased. Okay, the diode is reverse biased because I have already told many times in my previous videos. So that when diode is connected in this fashion with its N end connected to positive and P end connected to negative, the diode will be reverse biased. And when a diode is reverse biased, it behaves as an open circuit terminal. Okay. So, here the equivalent circuit can be replaced with a open circuit. So, during the positive half cycle, the diode is reverse biased and behaves as a open circuit. Now, because of this open circuit, now you can see that this resistance R and the load resistance RL are now in series connection with the input voltage Vi. Okay. So, now we can apply voltage division rule to determine the voltage across the load resistance, which is the output voltage. Okay. R and RL are now in series with Vi. So, when we apply the voltage division rule to determine the output voltage across the load resistance, we get V0 is equal to Vi into RL by R plus RL. That is the voltage division rule formula. Now, this value of R is generally very less as compared to the load resistance value. Okay, R is much lesser than RL. So, this R can be neglected or ignored with respect to RL. So, this R plus RL is nearly equal to RL. Okay. So, when we ignore this R, capital R resistance, it becomes the output voltage is equal to Vi into RL by RL. RL gets cancelled from the numerator and denominator, and we get the output almost equal to the input voltage. So, we get the same input signal or the positive half cycle as output, because the output is same as the input. So, we get the output as the same identical positive half cycle of the input AC. Okay, so you can see that in the negative clippers, the positive half cycle is passed as it is without any change or any cutting or removal in its signal waveform. It is passed as it is. So, the output is same as that of the input during the positive half cycle, exactly the identical positive half cycle of the input. So, this is the circuit behavior during the positive half cycle. Now, let us discuss the circuit behavior during the negative half cycle. Okay. So, this is the circuit analysis during the negative half cycle of the input signal. Okay. So, previously we discussed the positive half cycle of the input signal, the working behavior or the working of the negative clipper circuit. Now, we will analyze the circuit behavior during the negative half cycle. So, during the negative half cycle of the input sinusoidal signal, we have taken the input signal as sinusoid. The top end becomes negative and the bottom end becomes positive. So, as you can see here, this top negative end is connected to the N-type end of the diode, and this positive end at the bottom is connected to the P-type end. So, whenever you find a diode, a p-n junction diode connected in this sort of circuit arrangement with its p end connected to positive, n end connected to negative, means like ends connected to like terminals, this diode will be forward biased. Okay, so diode will be forward biased, and a forward biased diode in this case acts as a short circuit. Okay, a reverse biased diode acts as an open circuit, and a forward biased diode acts as a short circuit. Okay, so when this path gets short circuited, so the voltage across a short circuited path, you know that it is 0 volt. So the output across the load resistance will be 0, volt. Now what does this output equals to 0 volt signify? It means that during the entire negative half cycle we get 0 volt as output, no output during the negative half cycle. It means that this entire negative half cycle is removed or blocked or attenuated from the output. Okay, so this justifies the working of the negative clipper circuits. It justifies the name negative clipper because the entire negative half cycle is removed from the output. Because this diode gets forward biased and behaves as a short circuit, and the voltage across a short circuit is always 0 volt. So we get output equals to 0 during the entire negative half cycle. So the entire negative half cycle is removed or blocked, is absent from the output. Only the positive half cycle is passed, and it is identical, it's almost entirely, it is passed in its entirety. The positive half cycle is passed in its entirety, exactly same, because we saw that by applying the voltage division rule and we got the result. But during the negative half cycle, this diode behaves as a short circuit because it is forward biased, and the voltage across a short circuited path is 0 volt. So now let us discuss the input output waveform relationship of the negative clipping circuit.